The new topic that we have today is L'Hopital's rule. So we're going to go back to limits. We discussed how to do limits in a fair amount of detail earlier in the semester. So here are a couple cases of L'Hopital's rule. So if you're in a situation where you're taking a limit of a function over another function, if you're in a situation where the limit of the numerator equals 0 and the limit of the denominator equals 0. So our numerator is f of x. If that equals 0 and the limit of our denominator, which is g of x, equals 0, then we're allowed to take the derivative of the numerator separately from the denominator. So if you look at our notation here, we have f prime of x, so just the derivative of f, and g prime of x, if I haven't covered, let me get rid of that, and g prime of x below. All right, so you are not using the quotient rule. So not use the quotient rule. All right, so you're going to take the derivative of the numerator, leave it in the numerator. You're going to take the derivative of the denominator, leave it in the denominator. Now, please note that we keep our notation. See if I can do this correctly. We keep our limit notation here. We don't lose it in any way, shape, or form until we get a situation where we don't have a 0, 0, or if you look at the bottom case, an infinity over infinity, and the pluses or minuses don't really matter. Okay, so again, our case 2 is below here, where we have the case where the numerator goes to infinity, or limit of the numerator goes to infinity, or negative infinity, and the limit of the denominator goes to infinity. So here, essentially, we have limit of f of x over g of x as x goes to whatever, some number, or infinity if you prefer, or if that's the question. If this goes to 0 over 0, we do this. Here, we take limit as x approaches a of f of x over g of x equals infinity over infinity. And again, you're looking at two distinct functions. All right, so let me show you how this works. Let me scroll down and do a couple problems. So we're going to use L'Hopital's rule to evaluate these limits here. So let's do that first one. Now, the first one is a very easy limit that this question, in fact, I think has shown up on a quiz or test that we've taken before. And we note that we have a quadratic in the numerator and a quadratic in the denominator. So really, our limit is just going to be 4/3. Now, let's use L'Hopital's rule to verify that. So this, we know, equals infinity over infinity. If we just apply the infinity to the x squareds and the rest of it. Again, the x squareds are going to be the dominant ones. So this is going to go to positive infinity over positive infinity. So I'm going to use L'Hopital's rule. That looks terrible. All right, so I'm going to abbreviate it like that. And so this equals the limit as x approaches infinity of the derivative of the numerator. So the derivative of the numerator is 8x plus 3. The derivative of the denominator is 6x minus 2. So the derivative of 4x squared plus 3x minus 2, derivative of 4x squared is 8x. Derivative of 3x is just 3. Derivative of negative 2 is 0. Similar fashion, we're going to take just a general derivative of the bottom. No quotient rule involved. So this still equals infinity over infinity. So we do this again. So we're going to use L'Hopital's again. So this equals a limit as x approaches infinity. Derivative of 8x is just 8. Derivative of 6x is just 6. Derivative of those constants goes to 0. So we're taking x to infinity, but there is no x, so this reduces from 8/6 to 4/3, which is what we expected the answer to be. So that was a case where we had one that we've done before. Let me scroll down and let's do another one. All right, so here, this isn't one we've done in class, but we'll take this limit now. So we have two functions. F of x is 4x squared, that's in the numerator, and g of x. So this is f of x and g of x. And as we apply infinity, this equals 4x squared goes to infinity as x goes to infinity, as does e to the x. So we can use L'Hopital's rule. And take the derivative of each of them individually. So the derivative of the numerator of 4x squared will just be 8x. 2 multiplied by 4 gives you 8. X to the 2 minus 1 is just x. And the derivative of e to the x is just e to the x, so that stays. Now we get the same answer as if we input the infinity. 8x goes to infinity, e to the x goes to infinity. So we're still in a situation where we don't have an answer, and we're still in a situation where we can use L'Hopital's rule. So I will do it again. So this equals a limit as x approaches infinity of the derivative of 8x is just 8, and derivative of e to the x is e to the x again. Now we can evaluate this. So the derivative of the numerator is 8. There's no x involved. The derivative of the denominator is infinity, so this equals 0. So that limit is 0.